Good afternoon, everyone. I hope every one of you are doing great. Welcome to the classes of CS350, Digital Electronics and Pulse Techniques. Today, we're going to learn about a very interesting topic titled Introduction to the Triple Timer IC, which is a very important topic for understanding a significant aspect of this course, which is monostable, bistable, and astable multivibrators. And I'm Kazi Mubashir Tazwar, who will guide you to this mesmerizing journey of knowing this interesting IC and its impacts in our real life use cases. These are the contact details in the below. You can reach out to me for any queries regarding this topic and course. So, before jumping to the main discussion, it is very important for us to get an idea about what we're going to get at the end of the lecture, right? This is the overview of our lecture. We are going to talk about the real life cases first. What is a triple timer IC and how does the internal block diagram of it look like? We are going to also shed light on the operation and discharging process of it and the earlier mentioned three modes, the monostable, astable, and bistable multivibrator modes. So some questions might be arising in your head, right? Like why it is called a triple timer IC, or like where is this IC used? Why should we learn about it most importantly? Have you ever wondered the toys your nephews or niece plays with? How do they flashlights? Or how do the toy guns flashlights? Or how the timer of your washing machine in your veranda works? Here comes our hero, the Chauffeur timer IC. So let's move on and get to know about it in more details. It was developed by Sir Kazi in 1972, and it has a 8-pin diagram, right? And we can see in the right side, the ground pin, trigger pin, output, reset, power supply. The power supply is rated in between 4.8 volt to 15 volt. The discharge threshold and control voltage pin. This is the real picture of a triple timer IC, and it is widely used in pulse width modulation or pulse generation and timing and oscillation purposes. Now, coming to the internal block diagram part, it has predominantly 5 parts. The first one is the voltage divider circuit, the comparator circuits, the RS flip-flop, the discharging transistor, and the output driver. For knowing the complete operation of a triple timer IC, we have to know about all of them individually. How do the comparator work, or how does the voltage divider circuit work? We can see that it has 3 resistances in series, and all of them are rated 5 kilo ohm. So 5 kilo ohms are in series connection, right? So that's why this is called the 345 timer IC. Pretty simple, right? Let's now jump to how a comparator works and what is it. It is a digital circuit which has 2 points. First, the inverting port, and second, the non-inverting port. And according to the voltage on these input pins, it can output either low, digital 0, or high, digital 1. So first case, if the input voltage in the inverting port is greater than the non-inverting port's voltage, then it outputs low, meaning a 0 in digital. But if it gets reversed, the V in the inverting port is less than the non-inverting port's voltage, then it works as a high and it gives output 1 in the digital aspect. So that's how comparator work. According to the voltages in those 2 input pins, we can get either 0 or 1. It's like set reset logic. Now coming to the voltage divider part, the second important part of this device. So we have already learned about the circuit analysis techniques like Thevenin, Norton, KVL, KCL, mesh analysis, node analysis in the CS250. So still, we are going to review it. In this diagram, we could see 3 resistances, right, of the same 5 kilo ohm rating. And it has two ports, the VCC and the ground pin. So we can symbolize 2 points in this overall circuit. As it is a simple series connection and has same three resistors, the voltage drops in all of them has to be VCC by 3, one-third of the VCC. But what will be the voltage remain in this point, right? It will be 2 VCC by 3. Why? Because the first resistor has a voltage drop of VCC by 3. So remains the, what remains? VCC was the first voltage in this point. When a resistor gets a voltage of VCC by 3, it will remain 2 VCC by 3. So we can write that. And in coming to this point, it will only have left one-third of the VC because two resistors has dropped VC by 3 each. So this is what we can see in this diagram. The first point, it has 2 VC by 3, and the second point, it has the one-third of the VC. Now coming to the last part, the RS flip-flop part, it we can see the truth table of the RS flip-flop. But first of all, we have to know about the flip-flops in general. The flip-flops are basically building blocks of digital electronics, which are used to simply store binary data like 0 and 1. They're bi-stable devices because it has two states, stable states. First one is the set, and the second one is reset, high low. There are different types of flip-flops, D flip-flop, T flip-flop, JK flip-flop, and SR flip-flop are used one. So why didn't we use D, T, or JK flip-flop in our triple timer? We are going to discuss that in the next slide. But why did you use the RS flip-flop? Let's talk about that first. RS flip-flop is a very simple, fast, and clockless control. And as our triple timer needs a very simple set reset logic control, it is a natural choice. Also, it doesn't need a clock, and triple timer doesn't use a clock. So this makes it a very natural choice for it. And it has two inputs. Sorry, the S and R, it takes 0 and 1. We have 4 cases according to the combination. For first and fourth case, we don't really care for our operation, but still we are going to discuss the last case, 1 and 1. It is a don't care situation. It doesn't have an output. But for 0 and 0, the RS flip-flop output will be same as the previous output. But for 0 and 1, it outputs 0, and for 1 and 0, it outputs 1. So this is the low case, and this is the high case. So I guess we are pretty clear how the RS flip-flop tool works. So why didn't we use JK, D, or T? Why we use RS flip-flop? Because JK flip-flop is too complex for this simple logic of set and reset, and it also needs a clock, as the D flip-flop also needs a clock. And the T flip-flop toggles the input, and it doesn't ensure a precise control of the set and reset. But for our case, we need precise control. We want to control when the output will be on and when the output will be off. We need to control the duration of it. We can see that in this case, the output is on for a much larger duration than this. And in this case, the output is off for a much lower duration than this. So we need to control this precisely. So we can't use T flip-flop for that case. And as we don't have a clock in our circuit, we can either use JK or D. So now we know why we use RS flip-flop in this case. Now coming to the operation of a triple timer IC. According to our voltage divider circuit knowledge, we know that in this point, the voltage drop or remaining voltage will be 2 by 3 of VCC. And in the second point, it will be 1/3 of the VCC left. So we can see that there are two main points, threshold pin and trigger pin. And these are the inputs which the triple timer used to control the overall output of the circuit. The threshold is connected to the non-inverting port of the first comparator, and the trigger is connected to the inverting port of the second comparator. So according to that, we are going to talk about some cases in the triple timer. The first case, if the threshold voltage is less than the 2/3 of the VCC and trigger is also greater than the 1/3 of the VCC, then we can see that the threshold, the first comparator, positive voltage or non-inverting port has a lesser voltage. So the comparator will definitely output 0. But in the second comparator, as trigger, the non-inverting port is greater than the inverting port is greater than the non-inverting port, it will also output 0. So according to our RS flip-flop truth table, the output of the RS flip-flop won't change. It will be remain same. Like if the output was 0 in the previous case, it will stay as 0. So this case is not important for our operation that much, but this is a very important case, significant part. The test, if the threshold is two-thirds of the VCC and the trigger is greater than also 1/3 of the VCC, then both the comparators will output 1 and 0. So in this case, the RS flip-flop will output 0 and eventually the output of the overall timer will be 0. This means this is the low case. And for the next case, the threshold voltage is less than the two-thirds of the VC, and trigger is also less than the one-third of the VC. So the first comparator output 0 and second comparator output 1. And the overall output will be 1. So this is the high case. So these are the two cases we need to know and control. If this case is made, the RS flip-flop timer IC will be on. And if the previous case was there, then it will be off. So now coming to another significant process, the discharging process of a timer IC. So we can figure, we can see that if the Q is 0, RS output is 0, the Q bar will be 1 naturally, and it is the input to the base of the discharging transistor. So if the base gets 1, it will work as a closed circuit, and in this way, the capacitor will discharge. But if it is 0, it will work as open switch, so it can discharge. So this is a simple process of discharging the capacitor. As I mentioned earlier in the presentation, there are different modes of timer: the bistable mode, monostable mode, and astable mode. According to the use cases, we configure the timer with different resistors and capacitors and switches. So for this configuration, it works as a bistable mode. For this configuration, it works as monostable multivibrator. For this configuration, it works as astable mode. What are the use cases of it? The bistable mode, bistable multivibrator mode can be used as a flip-flop because it has two states, the high state and the low state, the two stable states. In the monostable mode, it behaves like a one-shot pulse generator. Like we will have only one pulse as output. We can like control the duration of it with the configuration of the timer with different ratings of resistor and capacitors. And in the last case, the astable mode, it functions as a simple square of continuous output generator. So according to our real life use cases or industry use cases, we configure timer in these three modes, and these are the three important aspects of our course. And for knowing this mode in detailed version, we need to have proper knowledge on timer IC first. So I guess we have had a introductory knowledge to this in amazing IC. How does it work, and what are the important parts of it, and how do they work individually or operate individually? These are the references we used in our lecture. You can go through them, and if you have any query about any links or any references there, you can reach out to me through my mail or contact info, or you can reach out to me in the next class. We'll have a short Q&A session, and I will try to answer all of your queries regarding this lecture. So best of luck, and till then, stay tuned. Thank you for your patient hearing.